Arithmetic can be very, very simple, but very powerful if you're clever about it and you know the principles really well. Lots of people feel like, yeah, arithmetic, that's fine, but they don't see these strange situations where arithmetic, the basics, give you these amazing outs into two situations, and we're going to look at one of those. We're going to take this integer 2 and we're going to factor it into a complex product. And if you're not too familiar with complex numbers, this maybe will work as an introduction. Uh, it's something that's hiding underneath this integer. If you can just bring it out, and that's what we're going to do today. I start with 2 equals 1 plus 1. 1 plus 1 is another way to refer to 2. And 1 plus 0 plus 1 is a valid thing to do. And I'll tell you why over here. I'll follow everything I'm doing over here. A plus 0 equals A. It's neutrality. So, and addition's commutative, so this will work fine. And then the next part, I'm going to do 1 plus I minus I. That we can do because 0 equals, of course, A minus A, where A is any number that we're working with. I is certainly a number. It's known as a bit of a strange number, but it's still a number. So 0 equals I minus I. Then here, what I'm going to do this time is I'm going to do 1 equals minus 1 times minus 1, right? So 1 plus I minus I plus minus 1 times minus 1. Next, we're going to note that minus 1 equals I squared. Why is this? Is because square root of minus 1 equals I. Therefore, minus 1 equals I squared. So just rewrite again. 1 plus I minus I. I'm going to take this plus minus 1 and just change it to minus. And that's going to be replaced with I squared. Next what I'm going to do is a little commutativity. For the next line, it's going to be A plus B equals B plus A. Just to be very clear, 1 minus I. This is getting moved over here. Plus I minus. I'm actually going to change the I squared into I. Just another way of writing it, but you'll see a structure a little better if I do it that way. So this part is very interesting because it is the property you have with multiplication and addition or subtraction. I'm actually going to do one thing before I do that. I'm going to do 1 times I minus I. Why can I do that? I can do that because 1 times A equals A. Simple as that. And here we're going to get to the interesting part. This rule is called distributivity. It's one that everybody knows, well, a lot of people know, but they don't always see how much interesting stuff it can get them. These techniques are just these tools that will only do great things for you if you know how to use them. It's about strategy. It's very much like following a maze or a chess game. So if you can see how to pull out the commutativity there, it's going to look like 1 minus I. Did I say commutativity? I meant pull out this I with distributivity. That's what I meant. 1 minus I times I. There you go. Right now I'm going to do a little associativity for the next step where, this is called associativity. And it'll just be like this. Some more room. And again, I'm going to do 1 times A equals A. But here, playing the role of A is 1 minus I. Plus, you know what? We're going to do a little commutativity on multiplication here as well. That's right. I'm going to rewrite this as I times 1 minus I. Right? Can you see it? Can you see what's happening? We're going to do one more distributivity. Ooh. One more where 1 minus I is playing the role of C, and 1 is playing the role of A, and I is playing the role of B. So 1 plus I times 1 minus I. And now we have successfully factored to the number 2. I bet you didn't know that the integer 2 had roots at minus I and positive I, just like polynomials have roots. And if you don't know what polynomials having roots even means yet, well, you'll be a little bit more prepared for that when you see it, because you can manipulate many more things than meets the eye into the form that shows roots than you might have thought if you thought arithmetic was just no big deal.